Hello and welcome to another episode of Construction Corner Podcast. I'm Dylan, I'm your host, and today, guys, we are going to talk more about design build versus traditional engineering, why even do design build projects, and how they can look at the end of the day, right? Why design build is on the rise, why more and more owners are deciding to go with the design build process, and what that can ultimately look like for you and your firm. So, really, what's the biggest difference that we're seeing and why the rise of design build engineering, design build projects over the traditional plan and spec process? Well, really, this comes down to timelines. More than anything, it's always a timeline piece. Timelines to really on the procurement side. If you're able to procure electrical equipment, air handlers, chillers, you don't really run into the timeline issues on plumbing equipment, but maybe for some larger plumbing items, you're going to run into it. But for the most part, it's on electrical panels, switchgear, transformers, utility entrances, right? And getting on the utilities schedule. Then on the mechanical side, it's going to be air handlers, chillers, large air handlers, chillers, things like that are going to be the holdup on the mechanical side for procurement. So when we talk about a lot of these things, if you're able to put a load together for the building, put in your utility applications, and then start that whole process with the utility and what service you're going to need for the building, how big it's going to be, the answering all the utilities questions to then get it in their engineering queue and pipeline so that they're able to bring, the service to your building. And especially on smaller projects, right? Like non-data center scale projects when you're only going to need 2-3 services of 4 or 5,000 amps. Really 4,000 is about the utility max, but 4,000 amp services by the utility at most, and at most 3 of them, right? So 12,000 amps at 480 from the utility is usually what we're talking about for your largest scale, commercial industrial user before we start getting into primary service and all those more complicated issues. But for most projects, the majority of projects, and getting your utility application in, the loads for the building roughly estimated, and knowing what you want to have as service for that building, then allows you to start the process with the utility. So in doing that, you're able to basically fast track the utility process. You're able to then start procuring equipment, at least like the main switchgear, and getting in the line for manufacturing. Because what'll happen is, let's say that lead time is, call it 42 weeks for a 4,000 amp set of gear. Well, in that 42 weeks, you're probably just in queue to be in production for 20 of those weeks. So then you have basically those 20 weeks or even 12 weeks to get through the rest of your design and engineering criteria to then be able to update any of the needs that you have for that piece of switchgear, the breakers you might need, the number of sections you might need, what that distribution looks like, to make those adjustments before your set of gear actually gets manufactured and produced, right? You're just waiting in queue for a big chunk of that time, but you can at least have pricing in and your spot in line, if you will, for manufacturing. Because you got to remember, a lot of, especially larger electrical equipment, is all made to order. Nothing is like out of the box or just kind of ready to go, sitting on the shelf. When you get into the larger electrical equipment, a lot of that stuff is made to order. And so you are just in line until it hits, the manufacturing queue for your particular piece of equipment. So when thinking about that, the sooner we can get in line, then we can get through the rest of design. But at least we have our procurement spot, and that goes for chillers and that kind of stuff are a little more off the shelf than electrical. And this is talking as a dumb electrical guy for mechanical side of things, and what those coils or anything look like on the air handler side. But if so long as you're going more standard equipment, not customizing it to the nth degree, a lot of that stuff does come off the shelf for the mechanical side. But again, you do have your delay windows from time your order was placed to time that piece of equipment's actually going to get manufactured and then shipped. So That's the big difference in design build is procurement timelines. Your timelines can get shrunk up, and engineers and the contractor working together to basically come up with, hey, not only will this work from an engineering standpoint, but we can buy the thing that we want. We've gone through all the procurement processes. We've worked with distribution. We've worked with all the other guys to do these things so that by the time that package gets delivered on site or to the shop, whatever that might be, you're ready to go, right? Everything is taken care of. Everything is buttoned up. Everybody's on the same page, engineer, contractor, everybody's in lockstep of what needs to be done on the project. And usually that means once it hits construction, everything is going super smoothly, right? Because all those issues have been worked out ahead of time and the engineer and the contractor are on the same page. And if anything does come up, because they're on the same team, it's going to be a whole lot easier to make those solutions and changes in the field to get a working solution with the equipment that they're able to actually procure, right? Something doesn't ship in time, something doesn't arrive the way that it needs to. Now you're able to make all those changes internally without having to go, back through the general contractor and make all those changes and you having to involve a ton of other people to get to the same end result, right? You can talk directly to each other. It's a lot simpler, a lot easier, and you're able to move a lot faster and come up with solutions to ultimately achieve the same end result that you're looking for. So huge piece in design build and why go that way. And then ultimately in needing an engineer for your given project, it's really how tight do you want to be on the things that you're doing. So I worked with an electrical contractor. They put together their own set of drawings, and I basically gave them some review comments that they could reduce quite a few of their wire sizes across the project. Really, I mean, that would have saved them probably tens of thousands of dollars just in copper, and in material. Now, whether they took that and reduced the wire sizes or not, that ultimately is on them to take those recommendations in reducing it, right, and updating their drawings accordingly. But the larger wire sizes that they had, the larger devices that they had in the project, are going to work just fine. But it's things like that to where, when you actually engineer it, you actually perform all those calculations, you're able to reduce your wire size, breaker size, and ultimately save more money on the project. Outside of, having to stamp drawings for permit and licensing and all those other things, right? We aim to basically not be a cost on the project, but to, one, as a double check and making sure that everything is done correctly, per code, and that wire sizes, circuit breakers, load sizes are all in there, but also to help those contractors save money, right? Not only do they have a good set of drawings put together, but to help them, be more cost conscious on their projects. Because if you start saving $10, $20, $30,000 on a project because you were able to reduce your wire size to actually what the load is, and we did voltage drop calculations and all the other pieces for that project, well, hey, that ultimately hits your bottom line, and you're going to make more money as a contractor, which that's the whole name of the game, right? Is to make money, be profitable, and all that kind of stuff. So huge piece in design build as well. And ultimately engineering should not be like a cost center for you guys. It should be something that helps you either make money or the confidence to go and execute that project really well, right? That it's coordinated, that everything's where it should be, circuiting's done, and your guys don't necessarily have to think through it. They can just go and execute the project, which is what we aim to do on all of our projects. So, and the last piece that I'll talk about here today is why do design build projects fail on the electrical side of things, right? Why would a design build project not go the way that it's supposed to? Usually the engineer and contractor are not on the same page. Sometimes you're getting distribution or other vendors involved or in the middle of the process that may or may not need to be or aren't cooperative. Because really the whole point of design build is to get all parties in the project, involved and on the same page. So if your engineer and your contractor are on the same page, but distribution isn't being a good, friendly partner to the whole process, well, it can fall apart there. Or your lighting rep and agency isn't doing the things that they need to, or they're not helping you out on the project to provide you the right photometrics or giving you updates. Or again, everybody in that whole ecosystem needs to be really a team player, knowing that everybody gets paid when the project goes. So that's where I've seen design build projects fall apart, or any project fall apart for that matter, right? Is the engineer and contractor not working together, not making sure that everything not only meets code, but it's the owner's intent, what the owner wants at the end of the day for the project, and to try to save it on pricing and everything else. So the more that everybody can be aligned and partners on the project, which I know is sometimes a hard word for people to use, but if you're aligned and really value what each other does in the process and helping each other to be successful for it, that's ultimately what it comes down to. So design build projects fail when not everybody's on the same page, not everybody's aligned, not everybody's working collaboratively to the same ends, right? And that can go for the contractors, double checking everybody or not, kind of letting each party do what they need to do. Distribution's not being helpful in it and finding creative ways to get the parts and solutions that we need. Lighting agency and not doing the photometrics that we need for the project, or, your engineers just not answering the phone or getting back to anybody. Those are the things that ultimately make design build projects fail, which is why we emphasize partnership, timeliness of response, and again, just being collaborative, right? Talking directly to the people that you need to talk to so the projects go over really, really well. And that, guys, is the big differences in design build versus traditional engineering. And that is this episode of the Construction Corner Podcast. Until next time.